Let's go back to our drawing and return to our camera here. So here you will find your trip circuit. Now, where does its DC come from? Its DC comes from here, and you will find trip 2 and something called trip 1. You will find that trip 2 comes from the DC panel or the DC or the distribution board. You will find Q2.6 and you will find Q1.6. You will see one comes from one bus and the other comes from another bus. They do not come from the same bus because in case the DC fails on this bus, both trip coils of the breaker should not be deactivated. You will find one comes from one bus and the other comes from a different bus. The trip circuit comes to you with positive and negative directly, whereas this one comes with positive and negative passing through an emergency local remote. So you would expect that one of them allows you to open or close in an emergency or local remote, while the other is dedicated to the A concept, specifically for tripping only. You might also find some interaction between them, which you will see now together. Here, engineer, is the trip circuit. Here is page 10A, which explains the A611, trip control A. The idea of the trip control circuit, as you can see, is that if you choose emergency, you will press select to open, which activates the main key 12. If you are in local or remote, it will go to the PCO to close or boot contact. When you close through it, it goes back down here to activate key 12. Here, there is no such thing as an interlocking condition, nor is there anything about a switch being closed or open. None of that. Here, I am done. Once I am done, or want to open the breaker, I must open the what? I must open the breaker. All right, that's good. So I opened the what here. Here, the cutoff switch is activated. This cutoff switch then comes to the post in my circuit, passes through the cutoff switch, and this cutoff switch goes to trip the breaker. All right, great. See the trip, all of this, here it is before it, one is open, one is closed. Okay, look at the DC mill. Here it went from here to that big box, which is set up here as a remote. It's labeled as a remote panel, meaning it's going to the remote panel. Engineer Karim raises his hand. Go ahead, Engineer Karim. If you want to open the mic, open it. I wanted to ask you about something, but the guys who are doing the injection test or something like that, they test the circuit breaker. Which coil do they break on? And if you want to test the trip, do you just want to open the breaker? Yes, I want to test, but I want to test by breaking on the relay coil to see if the trip function is working or not. Okay, you just want to open the breaker, meaning a normal bridge. When you do it here on the terminal block, it's X41, 60, and 62. This means you have activated the one that opens the breaker, or if you want to bridge it on itself, you'll find it here on page 17. You'll go here to page 17, like this, in the name of God. Here it is. This is 17 ABCD, here is ABCD, and this is the one responsible for the circuit breaker. Then you go to the back of the BCU itself, the back of the relay itself, and go to the pinout 44, which has terminals. You'll find a card with the number R, go to number 5 with terminals 5 and 6, and make a bridge between them to open the circuit breaker. If you want to ensure that all your wiring is correct from the BCU to the circuit breaker itself, and if you want to do the same action from above, from the protection room, go to the protection room and take all your lockout tags. Go to the protection room to your panel, which is called 6BB7. You will find in 6BB7 a lockout named 94BF11. Come to the back of this lockout, look or trip relay, look at its back, check your numbers. You will find odd and even numbers written. Follow the numbers and you will find at 22 and 28, make a bridge on them and it will deliver the trip to your trip coil. Is that your question? Yes, that's right, sir. All right, so you have the positive coming out here like this. The first thing it encounters is a normally closed contact from the breaker fail that I mentioned to you. Then it goes here and finds, for example, one from the trip relay, one from the lockout relay and exits. Notice where it enters, it goes up to the coil contact and exits from the contact itself and so on. We keep going in and out, in and out, in and out until I reach here to a resistor. Here, for example, it's a 3.18 kilo ohm or 3.300 ohm resistor, 38, 10 kilo ohms and 3,300 ohms. And it goes back to coil A. Then from coil A, it returns to the contact, then the contact, then the contact, then the contact. Then it goes down here to whom? To the trip coil. As for coil B, here it is. Doesn't it go down here? Exits from here with a wire, goes with it like this, goes with it here to a 3.3 kilo ohm resistor, and from there to coil B, and returns from coil B, goes down here like this, goes to the normally closed contact, and from there to the trip coil of the breaker. Excuse me, Bashar, could you please explain to us what these things are? Why didn't it go to the contact itself? What are these things? These things are not French. They are a finger type switch like ABB, for example. This finger type indeed is your test switch for situations when you are conducting tests or performing a trip test or doing anything on the protection relay and you want to isolate your trip circuit. So always all the turbine contacts are isolated through the test switch itself. All right, what you have in the cell or in your setup, this type, for example, is written for you, meaning you just open it for what reason? If you are working, it doesn't connect to what you have below. Where exactly in the setup? Coil A and coil B, these two are taking a normally open contact connected with coil C. Coil C is directly taking the positive from above and its negative is directly taken from below. All right, that's nice. So we have the same trip circle, and on top of that, we add the topic of the kit. Who is the kit? That's what the engineer talked about yesterday when we were discussing the SF6 gas. Here it is used and taken from the A from and at low stage 2. So if this happens, it opens and the timer starts to wait, counts the time, then stops. At night as it was initially. And this contact is open. It starts counting the time, then this contact closes. As soon as this contact closes, what happens is it immediately goes down or activates K80. So K80 opens the door here, preventing the operation of what? It prevents the circuit breaker from tripping. You have trip coil 1 and trip coil 2. Here, it places the gauge, and here it places the other gauge. These gauges prevent trip circuit 1 here, and this gauge prevents trip circuit 2. In my opinion, honestly, both gauges should, if either one detects a problem, prevent both. It would have been better if it took the timers that operate with the same auxiliary, and the auxiliary would prevent both. But anyway, that's not the issue here. According to the client, it's about what they want. I have no problem with that. Always be patient, especially when working with clients. The most important thing is that you understand very well what you're doing. You present the matter to them and say, honestly, there's this and that. If they agree, great. If not, there's absolutely no problem. It's not you who wants it that way. You're the one in charge. I presented it to you out of honesty. If you don't want it and your standard says otherwise, I have absolutely no problem with that. In the end, you find that on the positive and on the negative, you have an auxiliary delay for DC supervision on the trip circuit. DC supervision only monitors the positive and negative. It has nothing to do with the wiring above it or whether the trip coil is burnt or not. As long as it receives a negative from below and a positive from above, it tells you what the DC supervision status is, whether it's negative